use the intermediate value theorem to show that the equation e to the x equals the absolute value of x has a solution in the open interval from -1 to 1. So let's take this equation and rewrite it in a form that has a number on one side. So let's just subtract the absolute value of x to the other side. So we're looking for a 0 of the function e to the x minus the square root of x. Now, in order to use the intermediate value theorem, this function needs to be continuous on the closed interval from -1 to 1. So let's talk about the continuity. E to the x and absolute value of x are both continuous on the interval. They're both continuous for all values of x, so on the interval -infinity to infinity. And then if you subtract continuous functions, the difference of continuous functions is continuous. So the difference function here, e to the x minus absolute value of x, is also continuous for all numbers. And therefore, the function is continuous on the smaller interval -1 to 1. So we have continuity of the function. Now we have to show that 0 is an intermediate value. So we will take our function f of x here and we will plug in the numbers -1 and +1, and we should be able to show, we should see that one of these outputs is less than 0 and the other one is greater than 0, and that would make 0 an intermediate value. So f of -1 is e to the -1 minus the absolute value of -1. Let's put a -1 in there. E to the -1 means 1 over e, and then we have minus the absolute value of -1 is 1. E is approximately 2.7, so 1 over e is less than 1, because e is more than 1, so 1 over e, this fraction is smaller on the top than the bottom, so it's less than 1. And so 1 over e minus 1 is negative. This is a small number minus a big number, smaller number minus a bigger number, and that's negative. So f of -1 is less than 0. Now let's check and see if f of 1 is bigger than 0. If it is, then 0 is an intermediate value. We have a continuous function, an intermediate value, and so the equation will have a solution by the intermediate value theorem. Let's check. E to the 1 minus the absolute value of 1 is e minus 1, and e is about 2.7, so this difference is about 1.7, and that's bigger than 0. So 0 is an, I don't have to capitalize that, but an intermediate value for the function f of x on the interval -1 to 1. So by the intermediate value theorem, there exists a number c between -1 and 1, such that f of c is equal to 0, which is the same as saying that e to the c minus the absolute value of c is equal to 0, which is the same as saying that e to the c is equal to the absolute value of c. Just moving this back over, and that is the equation we wanted to solve. So c is a solution to the equation. So in other words, I could say, i.e., the equation that was given has a solution in the interval -1 to 1 as required. Let's take a moment actually and narrow down the interval a little bit. Let's see if we can find a smaller interval on which that equation has a solution. the x value 0 is right in the middle of that interval, so let's plug 0 into the function. F of 0 is e to the 0 minus the absolute value of 0. And let me put a better 0 in there. I started to write x again. So that's e to the 0 is 1 minus the absolute value of 0 is 0. So f of 0 is 1. So earlier we had said f of 1 was equal to e minus 1. And these are both positive. So in our analysis, we had f of negative 1 was negative and f of 1 was positive. We could replace f of 1 as positive with f of 0 is positive, and therefore by the intermediate value theorem, there is a solution on the smaller interval from negative 1 to 0. There is a solution to the equation in the interval negative 1 to 0. So we've halved the size of the interval. So now we have a more precise estimate for where the solution is.